Okay, so I think a lot of you are going to find this is a lot easier than what we've been doing. You know, yesterday was pretty heavy. Let's stop talking, guys. And the feedback from the first two classes was like, oh yeah, I remember a lot of this from Algebra 2. Okay, so what we're doing is more with logs. We are talking about the properties of logs. And you will notice that there's two columns here, one for logs with any base, and then natural logs. And I really actually don't like that she did that because they're the same. Natural logs are logs. And if you take a second and look from left to right, everything is the same in those two columns except one has the log base b and one says natural log. Okay? So I'm just going to be talking about this one. So there's three properties, and the first one is the product, meaning multiplication. And so what we're doing is taking a single log or condensed log and we're expanding it, okay? And then you're going to have some problems where you go the other way. So you can start on either side of this equal sign and write it the other way, okay? So when you're given a single log base b of m times n, right, that shows multiplication, you can expand it to log base b of m plus log base b of n. In other words, guys, Brandon, you guys, multiplication and addition go together, okay? And we'll apply problems to this in a second. The quotient property, quotient meaning division, log base b of m, you guys would probably read this out loud as over n, but that's divided by, right? M divided by n. You can expand it using subtraction, log base b of m minus log base b of n. So we should think of division and subtraction together. And if it's something hard for you to remember, you're never going to see like this division symbol. Very rare that we use that at this level. We usually see it as a fraction. And so the fraction bar looks like a subtraction sign to help you remember division and subtraction go together if you need to. The power property is if you have a log base b of any number to the power of p, you can rewrite that p as a leading coefficient. So the power goes and stands in front of the log, and it means multiply. Okay? So we'll apply all three of these here in a moment. I want to remind you of a few important things that are going to help us get through this assignment. So I would write these down. These are really important. First thing is, this property we learned, when you have a base and the same number, all of that to a power of whatever, we'll call it x, that will simplify down just to x. The reason is because of this fact. Whenever we have the same base and the same number, that completely simplifies and equals 1. It cancels out, basically. So going back to the green one, log base b of b is like 1, and you're just left with the x. How does the x get out of the air? The power property. Okay, so that x is really the p. So if log base b of n cancels, and your answer is just p, it's written on the ground in front. So then how about this one? What would this one equal? 1. What's the base? 10. You don't see it though, and that's why I'm writing it in pencil. I want you guys to get used to not seeing it. Log base 10 of 10 is always just log 10. So when you see log 10, you know it cancels out and becomes 1. Okay? This next one, everybody messes up on. In fact, it comes up in our notes here in a second, and then everyone already forgets it. What would this one equal? 1. That's right. Why? Tell the people that don't know why. Natural log is base e. Perfectly said, Sadie. Always. Never, ever, 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 in a million years before us and a million years after us, will you ever see anything written here. Ever. Nothing. Not even an e. Because it's only e. Okay? There's no other number it can be. So natural logs have a base e. So when you see natural log e, that's not the base. It's a bases are always a subscript. So if you don't see, every time you see a natural log e, it cancels out and just becomes 1. Okay? Everybody forgets that. Everybody. Okay. And then the last one is to remember that you can rewrite radicals as fraction exponents. And we see the square root all the time. The square root is always going to equal 1/2. Remember, this is a 1, this is a 2. And we go back and forth. You're going to be given fraction exponents that you have to write as a radical. So we can, go from left to right or right to left. So these are really, really, really important in being able to do some of these problems, okay? All right, so let's do going from single log to expanded and then condense into a single log. So take a second and look. This has got a couple of things multiplied together, 8x and y to the 4th. Oop, there's a power. So I'll be using the product power and the power. I'll be using the product property and the power property, okay? And I'm going to go slow with these and show a lot of steps, but by all means, when you get into the homework and stuff like that, you can start condensing steps. You don't have to show every row, but I am right now to help you guys understand it, okay? So I'm going to start with the word log, 8, right? Because it's multiplication, I'm going to switch to addition. Multiplication and addition go together. This is what I want you guys to remember. Common mistake is forgetting to give everybody the log. Everybody meaning 8, x, and y to the 4th. If you had the entire alphabet from A to Z in the parentheses, you'd have to write the word log 26 times. Okay? So everybody gets a log. Don't leave anybody out. It's rude. Okay? So then we have plus log y to the 4th. So that was applying the power property. Now that was applying the product property. Now we apply the product property. We're allowed to just simply put the 4 in front. So this becomes log 8 plus log x plus 4 log y. And I could totally see you guys combining those two steps and going straight to the green step. But we're not done in this problem. There's one more thing you have to look for to be able to simplify that this problem contains. And that is if the number in your log can be rewritten another way, we have to do it. And 8 can be rewritten another way. And what I mean is as a base of a number to a power. It's like simplifying a fraction or simplifying a radical. You've heard me say don't walk away from that radical until you make sure you reduced it all the way. If I was teaching a younger grade, I'd say before you walk away from that fraction, make sure you can't simplify it. Same thing here. Before we walk away from this log, we're going to see if there's anything we can simplify. And that 8 can be, because 2 to the 3rd is 8. So I have to rewrite that as 2 to the 3rd, which then applies the power property again. And here we go with our final answer. That 3 goes in front of the log, and then the rest of it. Plus log x plus 4 log y. Okay? That's easy to forget that you can do that. So let's talk about a few different numbers. If there was a 2 there, 2 to the 1st power, 1 goes to the front, it doesn't change. 3 can't be rewritten. 4 can, right? 4 would be 2 squared. 5, no. 6, no. 7, no. Yes, 8. 9 could be rewritten, right, as 3 squared. So that's what you're looking for, is perfect squares or perfect cubes. I don't think we go any higher than that, so that can be simplified. So we'll see that a few more times. Okay? That guy took up a lot of room. Okay, so in this one, again, natural log or log, it doesn't matter. All these properties apply to both, because this is just a fancy log. So we have division in here, so I know I'm going to use my quotient property and change this to subtraction. And I have a radical that I'm not going to leave in my answer. I'm going to rewrite it. Okay, so I'm going to start, again, I'm showing a lot of steps here. Natural log of the square root of x squared plus 5 minus, don't forget to give this guy a log, natural log of x. And then I say, okay, let's get rid of that radical like this. So I would have natural log in parentheses. You do need the parentheses. X squared plus 5 to the power of what? What would that be the power of? 1/2, yep. Minus natural log x. And then there's only one more step, power property. The 1/2 will go stand in front. You still want those parentheses. Sorry about this squeezing in here. Okay. Nothing else to do. Okay, so that's going from single log to expanded. We're going to go the other way now. We're going to go from expanded to single. So when you condense, your final answer should only have the word log written in it one time. Okay, so just like these, the word log was only in them once, and then we expanded it and gave everybody a log. In these, everybody has a log, and we're going to condense it down to a single one. Okay, so look and see what we have. We have subtraction, and I see a coefficient that should become a power. Okay, so this is going to be natural log of x to the 5th. Minus means divide. Okay, don't write natural log again. And then in parentheses, x, y to the power of 2. Now, there's so many things you have to remember for this class. We cover 500 different ideas a day, it feels like. And I'm like, remember back in 4th grade, how many times have I said that? Like, you had to do this, and now you have to remember this from Algebra 1, and this is one of those moments. How can I simplify this further? And I'm hoping your algebra brains see that we've got x's on top and x's on bottom that we can simplify. But to do that, I would need to first give everybody in the denominator that power. That 2 goes to both of them. So that would be x squared y squared. And now you can hopefully see that we can simplify this. What would that become? X to the 3rd? Yeah. We subtract our exponents. Remember, division and subtraction go together in more places than just here. So our final answer would be natural log. Where's the x to the 3rd going to go? On top. We always put our answers on top. Over y squared. And you guys said that really quickly, so it sounds like most of you knew that. But like if I gave you this, just this problem, forget if it was a log, you would all just write x to the 3rd. That's really on top, right? Because if you made it a fraction, x to the 3rd would be on top. So it's the same idea here. It goes on top, right? And that would be your final answer. So in single logs, you can have exponents. So that's a little confusing, I guess. All right, let's do one more of these. All right, I have a number in front. I think this should have been in parentheses to begin with, guys, just so you know. So there's a number in front that we can write as a power. Same thing here. We can write as a power. And we have plus, which we know is multiplication. So I have natural log of x to the 3rd y to the power of 3. I'm going really slowly here. Natural log of yz squared to the power of 2. So I just did the power property. Plus is going to become multiplication. And if you look ahead, there's some like terms in here. So when this becomes 1, we're going to be able to multiply. So I hope you guys are okay with me kind of combining 2 steps here. I'm going to go ahead and apply the 3 to everybody. Just like here, I applied the 2 to everybody. Okay. Let's not forget, though, that when you have a power already, you multiply. So this is going to become x to the 9th, right? 3 times 3. Y to the, that's a 1 right now, 3rd. Plus is going to become times this guy. Y to the 2nd, z to the 4th. I'm condensing it. So I went from addition to multiplication. So it's like going from here to here. When you have addition, you multiply m and n. So this is like m and this is like n. I'm multiplying. And I'm actually going to multiply them here. Okay? So that's going to be natural log 1 time x to the 9th. We have y to the 3rd times y to the 2nd. What would that be? Y to the 5th. See how you have to remember? Oh, when I'm dividing, I subtract. When I multiply, I add. Power to a power, I multiply. You're having to remember so much stuff. It's a lot. And then z to the 4th. And that would be your final answer. You do need this parenthesis. I actually should put parentheses here, so I apologize. Okay, I'm going to do some in the homework with you. All right, look at the next page. I don't like the way she did these notes, okay? So for the change of base formula, you write mine down. Change of base, and I'll explain what it means, what it's for in just a second. So change of base, you'll see me write COB. You know, I'm all about my abbreviations. Here it is. If you have a log with any base to any number, change of base allows us to change your log base 5, 7, 10 to a base, I shouldn't have said 10. It changes log base 2, 5, 7, 8, any number here to a log base 10, a common log. And I'll tell you why that's important in a second. So how you would rewrite it is log m over log b. Okay, I'm going to apply it to a problem right here and explain it. So in this level of a class where we use graphing calculators, in fact, you're required to use a graphing calculator on the AP exam. You can't even bring a scientific calculator. We are able to use the Math Alpha Math button to do this problem, right? So we would just do Math Alpha Math, log base 3 of 13, and get our answer, right? And you can still keep doing that, right? I'm not making you use change of base. But if you were at home or something and you didn't have your graphing calculator yet, you wouldn't be able to do this problem because scientific calculators, at least as far as I know, don't have a way of doing bases other than 10. But they all do have log base 10 buttons, okay? So this formula is going to allow us to use base 10 button, the common log button. So this is how you would rewrite it. You're going to put a log on top and a log on bottom. And how do you know which number goes where? Pretty simple. The base that's already lower goes on the bottom. Okay? It has to be in that order. And I'll show you, when I put this in my calculator, I will get the same answer. So that would be log 13, but you have to remember to close your parentheses, which a lot of people forget. Log 13 divided by log 3, enter, and you can see you get the same answer. Okay, so I don't care which one you use, and don't worry about writing the answer. I know you guys can write a decimal. Just know that this is an option for you, and I felt like even though we've used these calculators for these problems, if they meaning the test writers or something, ever refer to change of base, you'll know what they're talking about. It's just a way of writing any base into a base 10. Okay? But when you get to the homework, you can use this method. You can go back to Alpha Math Alpha and then just round to whatever it says. All right? All right, last question. This is kind of cool, actually. What this is saying is that we're given, let me start. Use the product property to show that this function is actually a vertical translation of that. So what we're going to do, guys, is we're going to rewrite g of x and apply the power property in this case. And what you're going to see is that's actually just taking a nice simple parent function and moving it up or down. So it'll make sense as we go. So I'm going to take this g of x, and I'm going to say, all right, we have 4 times x. Let's use our product property. Log base 2 of 4. Multiplication and addition go together. Don't forget, when you expand, everybody gets the log. So all I did there was put a plus in between them, basically. Remember, though, you always have to see if you can simplify. 4 is the same as 2 squared, right? Did I lose you? Oh, okay. 4 can be rewritten as 2 squared. Look at all those 2's, right? 4 is 2 squared. Dylan, you cannot have your head down in your class. Pay attention. You should have a pen in your hand and you should be writing. Log base 2 of 2 cancels, right? That equals 1. And that 2 comes down to the front. So that whole thing just equals 2. Log base 2 of 4 equals 2. You can put it in your calculator. You math alpha math with that, you'll get 2. And then we still have this guy over here. So we just simplified g of x from kind of if you didn't have a calculator, this would be a lot of yucky numbers in an xy chart, to, oh, I know how to graph the parent function and then move all my points up 2. And we're going to graph both of them together on here really simply. We're not even going to pick up our calculator because we are getting to know these log functions pretty well. And so we know all basic logs. Let me go up here to the f of x, where it started. Any parent function, no matter what the base is, every single one of them has an x-intercept of 1, 0. So, yes, of course that will change when we add stuff to the parent function, but no matter what the base is, a half, 2, it's always going to hit that point. And it's got a base that's greater than 1, so it's growing. I'm just going to go ahead and sketch it like this. Now, could you have picked up your calculator, put it in, looked at your table of values? Yes, but this is not a real true graphing exercise. I really want you guys to know the shape of it. Where's your asymptote? Where's your intercept? So that is f of x. That was the parent function. That's that. What do we do to get g of x? Move all of our points up 2. Well, let's just move this point up 2. Make sure we have that one good point. And you know that's just going to pull all our points up. We don't have to make it exact. They both still have this as an asymptote. Their intercept changed, points all moved up 2. But it's a nice, easy way of graphing. And so the very last thing we have to do, I'm almost done, is describe the change in output values over equal length input values. I think this is good practice to write things out in words. So from f of x to g of x, that's what they're saying. Describe what happened. As x values increase by 1, the y values increase, or no, let's not say increase. Let's say translate or shift. Translate up 2. That's what happened. So I'm going to do the first 3 homework problems with you just to kind of get you going. Then I'll put the key up and come around and help. So find your practice set 1. Write this down. 1 through 17 is the assignment, but as you can see, I wrote 11 and 12 are optional. They're a little bit harder. So if it's you're feeling a little overwhelmed, you don't want to do the 11 and 12, you can skip them. Okay, they're not going to be on a test. They're just lots and lots of things you can do to them. But you'll see them on the key if you want to try them. Okay? So the assignment, write it down so I can do some with you. I'll just do the first 3 with you. Okay, good? All right, so number 1, she should have had parentheses on there. I keep finding a lot of her mistakes. Okay, so log 32x, that 32x means multiplication, so when I expand it, it becomes addition. Right? multiplication to addition. Always check the numbers. In this case, there's only one, to see if it can be simplified. And we've seen it so many times already in this class. 2 to the 5th is 32. I would just memorize that because it comes up a lot. So that's log of 2 to the 5th power. So 32 is 2 to the 5th power. Bring it to the front. Question on that one? Okay. So this one's pretty simple. No powers, just one property to deal with, and that's the division one. So that's natural log 5. Division and subtraction go together. This is a common mistake right here. Students will put just y. It's natural log y. Everybody gets a log. Don't leave anybody out. It's rude. Okay, so we've got product and power. There's no number on the outside that we have to give to everybody. So let's just jump right in, excuse me, with natural log e to the 4th, multiplication, addition. Everybody gets a log, natural log y to the 6th. And you could have done this in one step. Bring the 4 to the front, bring the 6 to the front. Right, power property. Anything else I can do? Yay, yes. Remember, this is going to sneak in all the time. That's the one I was telling you about on the first page of the notes, that students just forget that that simplifies to just 1. And 1 times 4 would be 4. Not would be your final. Good job, Levi. Okay. I'll put the key up, and please let me know if there's anything I can help you with. Okay, just look real quick so I don't get everyone asking me. These change of base problems. She changed the base and then changed them to natural logs and then put it in her calculator. That's an option. I don't know why you would do that. She could have put the first one in the calculator. Why change it to that? It's maybe just to say that it doesn't matter. Or you could just use your math alpha to do those. Okay, so however you want to do those is fine. I just wanted to explain that she put that ln and F for whatever reason. I have no idea. You get the same answer. It doesn't matter.